Want to see something cool? This is a transparent calcite crystal which, while being one of the most common minerals on the planet, has a fascinating optical property. If I place this calcite in front of anything, whether that be text or an image, it will double it, creating a phenomenon which almost looks like wearing the wrong prescription glasses. The specific scientific term for this is birefringence or double refraction. But what makes this occur? Well, light from a given source contains both alternating waveforms of an electric field and a magnetic field. These two oscillating waveforms occur perpendicular or 90 degrees apart from each other. As a result, when light enters a substance or a medium with an arrangement of atoms and molecules that are not symmetrical in all three axes, the unpolarized light can be split into two separate polarized lights. But why would this division occur? Why would light suddenly bend? The answer is refraction. When light enters a medium that causes it to slow down compared to the surrounding medium, it refracts, aka bends, albeit only for the duration it remains in that medium. For example, you've almost certainly observed light refract when it enters water, making objects appear at slightly different locations than they actually are. This is because, while the speed of light is just under 300 million meters per second, in water this speed is reduced by 24.8% to around 225 million meters per second. To figure out the exact change in the speed of light for a crystal, you need to utilize this formula if you know a mineral's refractive index. Well, calcite is interesting because depending on the axis the light wave enters, it will experience two different refractive indexes. For the straight-moving light known as the ordinary ray, which does not bend, it travels at a speed of around 181 million meters per second. On the other hand, the extraordinary ray is actually faster even though it has to travel a longer distance, having a speed of around 202 million meters per second. This means that the extraordinary ray generally exits a calcite crystal first before the ordinary ray, and the bent light goes back to its original straight-line vector when it exits. This splitting of light is why images are doubled. But calcite is not the only mineral or crystal which experiences strong birefringence. It is just the most common one with a strong effect. Here are a list of some other crystals with strong birefringence, many of which aren't too common in both large size and transparent form, and then zircon added in with a less strong birefringence for comparison, with all relevant data coming from mindat.org. As you can see, the exact variation in the speed of light split into two does not always match up with the maximum birefringence values. However, when looking at the previous chart, you might note that of the 7 crystal systems minerals can have, one in particular never pops up, almost never having any level of birefringence with only one exception. And that crystal system is isometric since its unit cell has angles that are all 90 degrees. Out of the 540 isometric minerals, only one of these has a non-zero birefringence. The mineral in question is known as Pharmacosiderite with a birefringence value of 0.005 or 34.4 times smaller than that of calcite. Birefringence is just one of the many fascinating optical properties a mineral or mineraloid can possess that I plan to eventually discuss in the future, including but not limited to opalescence from opals, labradorescence from labradorite, angelorescence from moonstone, and chatoyancy from tiger's eye. Please let me know which of these you would like to learn about next. As a final note, I would like to thank my new patron GauntDayNG for supporting my work.